So we know about photosynthesis. We know that photosynthesis is water and sunlight and CO2, and then we create oxygen and glucose. However, in the early days of Earth, we didn't always have an abundance of sunlight, considering maybe there were some gaseous clouds that didn't let the sun get through all the way. You had stuff deep in early oceans that had no way to get sun. You still have things that can't get sun now. So there had to be other ways to get energy. And the answer is chemicals. This may seem weird, but there are actually organisms that can take elements and chemicals and use them in a process to manufacture their own energy. If we use the sun, we know from previous units that is an autotroph, automatically making its own energy. So if we use chemicals, using the prefix for chemicals that we usually see, like in chemotherapy, we get chemotrophs. Now, this can be really complicated. For example, on the sea floor, there are places where there's no sunlight, so they have to use whatever they can find. In this case, a hydrothermal vent, which is spewing up elements from the Earth's core, is going to spit out hydrogen sulfide. And you have kind of a modified version of photosynthesis. CO2, water, hydrogen sulfide, instead of sunlight, creates the C6H12O6, which is glucose, and it creates a bunch of sulfur compounds. So instead of spitting out oxygen, you get a weird sulfur compound, but you still get your glucose, so you can still use the mitochondria, you can still break it open, you still get the energy from it. Autotrophs use photosynthesis, because they synthesize it using photo light, and as you can probably guess, chemotrophs go through chemosynthesis. I know, right? Can you believe that the words make sense? This is what largely existed in early Earth. Chemosynthesis, chemotrophs, because there was not a whole bunch of great environment. You had toxic fumes, you had a little bit of CO2, you had sulfurs, you had methanes, you had all this garbage. You didn't really have a nice, stable environment. So the question is, how did we get oxygen? Like, where did oxygen originate? Because oxygen, while bound up in other compounds, was not a huge component or at all a component of our early atmosphere. The percentage was far too low for us to even utilize. So how did it all start? Just like any change in any species on a planet starts, mutations. You had bacteria and all kinds of stuff that were using carbon dioxide, water, hydrogen sulfide to make sugars and sulfur compounds. That's great. However, at some point, something had to mutate. Something had to figure out there's a large source of energy beaming down photons that nobody's using. And again, just like any mutation, it was a typo. It's a mistake. It was something that did not originally start out that way, and it wasn't intended to happen. But at some point, the guys who were all using hydrogen sulfide accidentally created, through a typo, something that could use sunlight. The one that we largely attribute to this is called Cyanobacteria. This is what we believe were the first photosynthesizers on the planet Earth. They do the process we're super familiar with. They took in sunlight, they took in water, they took in CO2, and they gave out oxygen. There's lots of hydrothermal vents on the floor, and that's great. Hydrogen sulfide comes out of them if you can find them. However, by far more plentiful is sunlight. So while it's great that bacteria can live down here near the hydrothermal vents, eventually the mutants that could actually absorb the sun's rays were more fit. Remember from natural selection, fitness means you're more likely to survive. It is way easier to get sun because the sun is all over the place. It's coming from space, it's hitting, there's way more of it. Guys that use photosynthesis as their process for energy can therefore be all over the place. Chemosynthesizers still exist. They have not become so unfit that they have gone away. However, the frequency, number, and the sheer number of guys who could do photosynthesis went up. These guys may have gone down because there were less and less of them, their trait was less fit, but they still had places to go. They still had environments where there was no sunlight. And you can kind of see, if I just am making up the general term, there's kind of a point where photosynthesizers no longer exist because the sun cannot penetrate that far down into the water. But on the surface, where you can actually get sunlight, photosynthesizers took over. They began to use the sunlight like crazy, and as a result, they spewed out our friend oxygen. As a result, the atmosphere becomes more and more and more oxygenated. And because of this change, because this shaped the environment, now you have this abundance of oxygen, like actual O2, floating around in the air. And just like the bacteria mutated, at some point there had to be an organism that mutated that could utilize this oxygen. It had to be able to take in this oxygen and use it for its process. Now, you don't really need to know about endosymbiosis, so I'm going to spend about 60 seconds on it, just because it's super interesting. Endosymbiosis, or the endosymbiotic theory, basically says that the first cyanobacteria, some of them could do photosynthesis. Because of this, oxygen started to increase. You then had things that popped up that could use this oxygen. Very, very similar to our modern day mitochondria. So say you got the DNA of each of these bacteria. Over here is some random organism. I'm going to say organism A. Through relationships and through mutual and symbiotic relationships, these guys are theorized to have slowly migrated into this guy, whatever this is over here. Species A has his DNA here. He's got something that can do photosynthesis here. He's got something that can do cellular respiration here. Again, at some point there was a mistake. And while splitting this cell to make a second cell, they usually have to just look at the DNA and double the DNA. They also looked at something in here, maybe accidentally, looking at the DNA of another bacteria. And in this case, completely accidental, created something that was basically born with the chloroplast and mitochondria already inside. Because it was such a huge advantage to have these dudes living in you from the start, rather than hoping they move in, they took off and went crazy. So, the mitochondria in us and the chloroplasts and mitochondria in plants are theorized to have initially been a separate entity, a separate organism. And all of this basically originated by mutations and changing environment and the differences in energy acquisition. So you largely have these guys to thank for all of the processes you can do, because all of our processes evolve from them and are because of them.